Okay, we are partway there, but what sucks? Well, this getLongestName function, it's going to get called for every node in the tree. And as our tree gets bigger, it's just going to get called more often. Same thing goes for the findIndent function. And then we have this label thing that's causing a leak. So those definitely need fixing. And one thing that we haven't tried is to see if this longest name updates when nodes are removed or added. So let's run this. Let's remove a node and see what happens. All right, let's get rid of this longest one. Okay, that's cool. So it updated it correctly that way. Let's put it back. And let's add a node and see what it does. Its name isn't longer than the longest, so the tree didn't need updating. And let's change the name and make it a super long name. We'll just type a bunch of junk letters and see what we get. Okay, so no update. Hopefully that's an easy fix. I think we can just do name changes, result in the value tree property changed callbacks firing. So let's just make that callback update the tree. All right, let's get rid of this. And we'll just force kill it so we don't have to deal with that leak. And let's go down to our property changed callback. Value tree property changed. Okay, so we will do tree has changed. Okay, let's try this. Oh, I should probably spell that right. Tree has hanged. All right, let's add a node and give it a super long name. Awesome. That's cool. That was an easy fix. Very cool. Whoops, I keep forgetting about that leak. All right, let's figure out how to make it not call getLongestName for every single node in the tree. Let's just think about what happens every time we check for the longest name. So we pass in the tree root to some function, and as long as that tree never changes, we don't need to check for a new longest name. So what constitutes a change in the tree? Well, that would be any property change or any child removal, addition, or reordering. Okay, so for some child node calling getLongestName, it's passing the same root as some other child node or some parent node, right? Does that make sense? Do you see where I'm going with this? If we have some tree to compare against for changes, we will know that we need to recompute. Okay, so let's write a struct that has a tree we can compare against. This should be an interesting problem to solve. Let's put this above our getLongestName and put it before our node length. We'll just toss this right here. Struct length calculator. That seems like a good name. And let's give it a tree to compare against. Private. Let's see. Value tree root. Okay, let's give it our getLongestName function. But this time we're going to check if the tree passed in is different from the one that we're storing. And if it's the same, we will return the node info that we already calculated. So that means we need a node info member. Node info winner. And this should probably return a reference instead of a, well, no, this is totally fine to be returned by copy. It's not that big a deal. So let's keep our indenter text. Just grab this, copy it. So now we just check if our trees are different. If root does not equal tree, then we can say root equals tree. And then we would do our computation here, do computation here. Okay, we're gonna need to return the winner, return winner. If our root is the tree, then let's just, give ourselves a little message about that. Else debug indenter. Oh, not that shouldn't be quoted. Indenter already computed. All right, we just give ourselves a little message that, hey, we already did the computation. All right, let's do this computation here. Okay, so it's basically going to have the same guts as our old getLongestName function, but we can't call our member function getLongestName anymore, so we need to call something else, like run computation or something. It was a free function before, so let's make it a static private function here. We'll just do this static node info run computation. Same signature as before. And let's call it right here. And we have our stub in place. We'll call it winner equals run computation. We're going to run it with the root and with our tree view. And let's see. Now we just need to copy these guts over. These guys right here. Let's clean out this stuff. Well, we'll clean it out in just a second. Copy this. Let's paste it here. Let's get rid of these this commented code. Now this is a static function, so it's totally fine that this has the same name as our member. Now all we need to do is not call getLongestName. We need to call our static function. So now in getItemWidth, we can come down here. In getItemWidth, let's see, we can get rid of, not get rid of, but we can make a static length calculator. Static length calculator. Length calculator. And instead of calling this, we can just call length calculator dot. Length calculator dot getLongestName. All right, let's try it out. Okay. And let's delete this super long node's name and see what happens. So it didn't update the tree. And do we have anything here? Okay, look at this. It's all the same name is always it's always showing always computed, already computed, already computed. Okay, so is there anything else that was going on in here that was weird? Let's see, let me add a task. And let's remove it. Okay. So let's see. I think I have an idea about this, but let's take a look at the docs real quick. Let's go to our tree view value tree docs. See what we can find over here. Changes this object to be a reference. Wait, maybe it's, what's going on here? Returns true if both this and the other tree refer to the same underlying structure. Note that this isn't a value comparison. Two independently created trees which contain identical data are not equal. Okay. Oh, so, you know, I figured something like this might happen. Part of the reason that we can pass value trees around by value is that they are reference counted objects. So look at this guy down here, is equivalent to. Performs a deep comparison between the properties and trees of two children. And let's see if all the properties and the children are the same. Recursively, this returns true. The normal operator equals only checks whether two trees refer to the same shared data structure. So use this method if you need to do a proper value comparison. Okay, that's probably the problem. All right, let's go over here. That means we probably need some other way to copy. Let's see if there's another way we can do our copying. Oh, here we go. That was conveniently right there. Create copy returns a deep copy of this tree and all of its subtrees. Okay. All right. Sounds like we know what we need to do. Well, first of all, we can get rid of the old. We can get rid of the old getLongestName. So we can get rid of this, and we can clean up all this dead code as well. This stuff as well here. Okay. Let's go up here to our comparison guy. And let's get rid of this. We're not going to use that not equals. We're going to use if root dot is equivalent to the tree that's been passed in. We want to make sure it's not the same. And then we can do our make a deep copy. Root equals tree dot create copy. Whoop, not XML. All right, let's try this out. All right, let's add a subtask. Okay. And let's make this a super long name. Okay, that works cool. And if we remove this, okay, that works as expected too. And do we still get drag and drop if we make this here? Yes, awesome. That works as expected. Ah, we still have that leak. Okay.